In this paper, we introduce a visual analytic approach that uses different dimensionality reduction and clustering algorithms to visualize and group different components of heterogeneous and multidimensional machine maintenance data. We'll illustrate the use of our approach using one use case scenario. In this scenario, we use machine maintenance logs of heating, ventilation, and air conditioning, or HVAC systems, used in a set of office buildings at the heterogeneous dataset. After loading the dataset into the system, we see the dimensionality reduction and clustering results for all three types of data. Currently, the categorical data panel is activated. The clusters are represented with different colors, and we provide default tags for them based on the problem and solution descriptions in the logs. We can click on one hexagon, cluster, or brush an area in the projection view to select the data and see their correlation with the other two data types. We can also check the contribution of each category to current cluster by examining the cloud of individuals, where each dot represents a maintenance log, and cloud of categories, where each dot represents a specific value of a certain categorical feature. To look for category values that contribute more to a selected cluster, we look for dots from the cloud of categories, located at roughly the same area as the colored dots in the cloud of individuals. We achieve this through a new contrastive learning method called contrasting cluster in multiple correspondence analysis, or CCMCA, that we introduce in this paper. The numerical data panel is supplemented with a feature contribution panel, which we can examine by hovering over the corresponding square in the heat map. Finally, the text data panel is supplemented by a keyword frequency plot. When no cluster is selected, we will see the distribution of keywords in the whole dataset. When we select a specific cluster, the keyword frequency panel is updated to show the top keywords from this cluster in contrast to the overall dataset. By looking over the tags, keywords, and large clusters, we find the dataset contains several complaints related to room temperature, with the tags too hot and too cold being the most common. Temperature-related complaints are typical for HVAC systems in most offices. From the text dimension views, we also notice a unique brown cluster tagged as fan, alarm, fail. The top keywords in this cluster include fan, alarm, fail, reset, repair, which are significantly different from those in the rest of the dataset. This cluster overlaps with all clusters in the categorical view that have fan, alarm, fail as one of their main tags. The highest overlap is with the cyan cluster tagged with alarm, reset, fan. We can use Boolean operators to separate the intersection between these two clusters. From the category contribution panel and the slide-out tabular view, we can see that several types of equipment, such as RAF, EF, VSD, CRU, and AHU, contribute the most to this cluster. By consulting domain experts, we learned that such equipment has always had relatively unreliable fans. Finally, let's check the numerical data panel. It appears that the labor cost for this problem is relatively low, so we can suggest having regular preventive maintenance done on this equipment. We evaluate our approach through an expert study, and it highlighted the usefulness of these linked views to characterize clusters across different dimension types. For details, please refer to the paper.